This is Geometry Unit 8, working on Day 7, about arc measures. First, we're going to talk about a central angle. A central angle, just as the name implies, it's central. It's in the center of the circle. An angle with a vertex at the center of the circle. So a diagram looking figure of this, I make the circle dash just because it's not the main focus of this diagram. The central angle has a vertex at the center and then opens up to the circle. A minor arc. It's part of the circumference, measuring less than half the circle. So our figure, an arc is part of the circumference. So we're coming around the edge. And that would be an arc. Part of the circumference, but it's less than half the circle. A semicircle. That's part of the circumference. Measuring exactly half the circle. So we take our circle, and a semicircle would touch both ends of a diameter. If you had a diameter going through there, it would touch from one end point to the other end point of that diagonal diameter. Major arc. As the word implies, major. It's of course part of the circumference. Measuring more than half the circle. So you have less than half, you have exactly half, and then you have more than half. Very similar to an acute angle, a right angle, and an obtuse angle. But that's measuring 90. Arcs measure up to 180 or more. We'll talk about that here in a second. So we have our circle. A major arc is going to be part of the circumference. That measures more than half the circle. So half the circle would be to about here. This is more than half the circle. When we talk about the arcs, the measure of the entire circle all the way around is 360. The measure of a minor arc is the measure of its central angle and minor arcs are always less than 180 degrees. So this central angle concept, if we look here at the bottom figure, we see that the central angle has 50 degrees. So the measure of angle ACD is 50 degrees. Well, notice how this central angle comes up and touches arc AD. So the 50 is also the measurement of that minor arc. So the measure of arc AD is going to be the same as the central angle, which in this case it's 50 degrees. The measure of a major arc is the difference between 360 and the measure of the related minor arc. And it's always more than 180. So notice, if we wanted a major arc, like from D all the way around, so you could call that DBA or ABD, all over here, you could take 360 and subtract a little bit that you aren't interested in. Or you could add up the central angles or arcs that make up that larger portion. We're going to get rid of this arc symbol. It belongs up there. So the measure of arc ABD, you've got to use 3 letters if you're talking about a major arc. It tells you, if you only use AD, you wouldn't know that they expect you to go around the long way. So you put in another letter, doesn't matter which letter it would be as long as it was part of the circle in the arc that you're talking about. The only one that we have labeled is point B. So ABD. So the measure of arc ABD is the whole thing, 360, minus the 50. That gives you 310. The other option that you could have done, you could have talked about how if this was 50, the remaining part of the linear pair would have been 130. And then, of course, this side is 180. So the 130 plus the 180 gives you 310. The measure of a semicircle would always be 180 degrees. So an example of that, the measure of arc ADB, again, we have to use the middle letter D because it's telling us which side of the semicircle that we're talking about. Are we going to go up and around, or are we going to go down and around? If it has the D there, it's telling us to go up. It would need another letter along our circle if it wanted us to come down this way. So its measure, because it's half the circle, it goes from one end point of a diameter to the other, it's going to be 180 degrees. On the next side, we're going to name the arc that's in bold, and then we're going to say if it's minor, major, or a semicircle. So here we see the bold part. It's smaller than half the circle. Half the circle would come all the way over to here. So we know that it's a minor arc. And the measure of AB, arc AB, well, I'm sorry, we don't know the measure of it, but that's its name, arc AB. We're supposed to name the arc, and we're supposed to say if it's minor or major or a semicircle. So here We have a major arc because it's over 180. So we're going to need to use 3 letters. So we'll start with an endpoint of the arc. We pick another point that's in that arc, and then we end with the other endpoint. We don't need to use the M with it because we're not talking about the measure in terms of the value. We're not talking about the degree. And this is over half the circle, so it's a major arc. Here we have half the circle along the circumference. So half the circle is going to need 3 letters again. So we of course are going to have the starting and ending points, plus we need another point in between. The book's pretty consistent at that. There's a time or two that it seems to fall off of that description. So we know this is a semicircle. So next, we're going to look at finding the measure of each of these arcs. Here's circle C. That's your notation for naming the circle. We know that AB is a diameter. And we're going to say if it's a major, minor, or a semicircle. The first thing I would suggest is to take your picture and let's label as much of the information that we know. Since this central angle is 135, I know this arc up here is 135. Since this is a linear pair, it adds up to 180, then I know this is going to be 45. Since this central angle is 45, this arc measure is going to be 45. This goes from endpoint to endpoint of our arc. We don't have another letter to name that side, but it would still be 180. And this would be considered a straight angle of 180. So now we should have enough information to come over and answer these questions. So we're supposed to find the measure of this arc. So we'd say measure arc DB, and we can see that arc DB is 135. That is a minor arc. So that tricks people occasionally because it's still a number bigger than 90, and you're so used to thinking smallest is less than 90 with acute angles. But with arcs, small arcs or minor arcs are less than 180. DAB, now I know this is going to be 180 or bigger. So the measure of arc DAB, from D to A to B, that's going the long way around, not the short DB, but the longer way around. One way we could do that is to say 360 minus the part we're not interested in. That gives me 225. Another way you could calculate that is to say 45 plus 180 would also give you 225. You could add up the arcs or the central angles that take you for that same intercepted amount. Next we're going to talk about arc ADB. That's coming up over the top, A to D to B. From A to B, that is the segment is a diameter. So the arc ADB is going to be 180. And that's considered a semicircle. This one would have been over 180, so this one's called a major arc. two arcs of the same circle are adjacent. They're side by side to each other if they share a common endpoint. And one example of this, sharing a common endpoint, would be AD and then D to B. Those are two arcs that are side by side. Notice that they both have the same letter in them. They both have a D, meaning that they're sharing that same endpoint. They don't overlap. They don't have a gap in between. They have a starting point to ending point, and then it opens up to go the rest of the way. Arc addition postulate. Just like we've had segment addition postulates and angle addition postulates, we're now looking at arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So in this case, if we're going to look at this big arc, this major arc, we name it with ABC, arc ABC. We would say that the measure of arc ABC is made up of the two smaller arcs. The measure of AB, arc AB, and the measure of arc BC. So down with example 3, we're going to have some adding to do to try to figure out some of these measurements. When we look at our figure here, this lowercase r, it kind of looks like, is actually a capital T. And then this funny check mark is actually a V. So we're looking for the measure of RU. From R to U, it's only two letters, so you know it's going to be the quickest way around. It's the 60 plus the 80. (140 degrees). Next, we're going to look at RVT. RVT adds our three angles together. So we could say from RV all the way to T is 60 degrees plus 80 degrees plus 90 degrees. We know that's going to add up to 230 degrees. Another way you could look at this one is to say 360. It would have been everything but the part that we're not interested in, which is everything but the 130, which gives you the same result. Either way you want to calculate it. The measure of arc RT. From R to T, we're looking for the shortest direction for that because it's only two letters. That's 100 and that's 30. And then this last one, U, ST. Now we could have picked any of these other letters, UVT, URT, or UST. They named it UST. And it's the measurement, so we're looking for the degree value. That's going to be 80 plus 60 plus 100 plus 30. That's one way for us to add this all up. And we'll get 270 degrees. Another way to have done it is we wanted everything but the part we're not interested in, which is 90 degrees. So we could say everything minus 90 also gives you 270. Two different ways of thinking about solving for the measure of that arc. Alright, last example. We have segment, because of the segment bar, segment AC and segment BD are diameters. So for circle E, you're supposed to have two diameters running through it. So there's our circle with E. We'll have our first diameter go through here, and we'll call that AC. It wouldn't matter at which angle you put it in. Now, for your arc measure to actually look like 316, we don't want to put the D right next to the C. We want to go 180 plus we want to go more degrees to get around. 180 plus more gets you to 316. So I'm going to bring arc BD. Be sure that my D is way down here. So now it might even look like 316 degrees. The arc measure is the same as the central angle, which is 316 degrees. If that's 316 degrees, then we're going to subtract it from 360, which is the whole circle, and I see that I have 44 left. So that gives me my central angle of 44. You got to think about your problem solving skills and trying to figure out what information they've given you and how is that going to help you figure out other measurements in the figure. If this central angle is 44, then we know that the intercepted arc is 44. We also know vertical angles are the same measurement. So those are both going to have central angles of 44, and the arc is 44. The central angle next to it, either direction, the central angle is going to be 180, not counting that 44, which is going to give me 136. So that's going to be our arc measure, and then you would get the same thing on this side with an arc measure. Okay, the 316 is the distance all the way from A to B to D. 136 is just from the C to the D. So now, since I've taken the picture, I've broken it down and found all my different measurements. Now I would suggest to try to calculate different answers. We want the measurement of arc AD. Well, we figured that out to be 44. Now we're going to look at arc BC. And that's also going to be 44. For the reasons we talked about, you'd have a central angle, another central angle because they're vertical, and intercepted arcs are the same measure. Minor arcs are the same measure as its central angle. It's called an intercepted arc because the angle opens up and it's touching the circle at 2 points, which makes this arc. It's called an intercepted arc. The measure of arc BCA. BCA. It's the 44, the 136, and the 44. It's everything but the 136. So you could call this 360 minus the 136. And that would give us 224. Or from B to C to A, that would be 44 plus the 136 plus the 44. Either way, we would get 224 degrees. So this last question, we're looking for the measurement of arc DCB. DCB, we're going that way. Well, D and B that segment is a diameter. So arc DCB is also a semicircle. So that's going to be 180 degrees.